recording now. Lauren, we are not able to hear the video.
Do I need to be unmuted for this?
Let's see if that changes it.
Over data centers here in Kentucky and recently lead to a meeting tonight of residents in West Louisville who already see one being built near their homes. It is our top story for you here on the night team. Hello, everybody, and thank you for joining us. I'm Doug Proffitt. We checked the data center map. It's a resource launched in 2007 used by buyers and sellers of data center services. Kentucky has over 37 data centers with 24 in Louisville alone. There are smaller data centers scattered around the city that provide IT infrastructure and data storage to business sectors like healthcare and retail. Now, these centers have significant energy and gas usage compared to residential consumers. However, they cannot compare to the massive data center projects you've been hearing so much about in the news lately. WHS 11 Night Team's Alex Dieterer covers the new concern from a group of West Louisville residents.
I live in Rubbertown, and we've already got a whole host of problems.
Kentucky's first hyperscale data center is under construction on Campground Road, expected to cover these 157 acres near Rubbertown. Rubbertown residents are left with questions and concerns that UofL Assistant Professor Dr. Natasha DeJarnette helped address through a West Jefferson County Community Task Force meeting.
So people care very deeply about how the presence of data centers in their communities will affect not only their lives, but the lives of their children.
But data centers are not a new concept. Right now, there are at least 24 just in Louisville.
They've been an extra floor, an extra building attached to a hospital or to a bank, and nobody noticed them because they were doing great things for us, but they didn't require massive amounts of energy and of land.
UofL toxicologist Dr. David Hines said the rise in these massive data centers is due to the rapid increase of artificial intelligence.
It can provide increased tax revenue to states and counties, and increasingly the artificial intelligence that makes our life much easier.
While on the flip side, the energy used by data centers can have adverse impacts on air pollution, which can lead to heart and lung complications and diabetes. Studies show that industrial pollution in Rubbertown already contributes to health disparities in the area.
It should not further add to areas that are already burdened when it comes to air quality and health outcomes.
For some communities that are becoming the host to the centers, they say the benefits don't outweigh the risks.
Did anybody ask AI what would be the best place to position the data center to have the least impact on society?
Essentially, Google said to locate them away from people. That's a quote of Google.
A growing conversation surrounding data centers that seem to be here to stay. In Louisville, Alex Dieterer, the WHS 11 Night Team, on your side.
Louisville Metro Council member Marcus Winkler has proposed a data center moratorium, a hold right now in the city. The moratorium would not impact any current data centers that are under construction, like the one we just showed you on Campground Road. The Metro Council did not vote, and they instead tabled the moratorium proposal, and that happened earlier today.
Thank you so much, Lauren, for sharing.
All right, we're back with Zach Call to talk some more
Lauren,
security. This is episode
number
number 3 of 4.
Thank you. All right. And now we'll prepare to hear from our expert speaker today. Our speaker today is Mohana Gutta. She is a PhD candidate in electrical engineering at the University of Louisville, focusing on data-driven analysis of power, carbon, and infrastructure systems for hyperscale data centers. Her work leverages Python, statistical modeling, and dashboard development to support energy efficiency, grid stability, renewable integration, cooling optimization, and scalable infrastructure for planning resilient facilities. So we are really excited for her to introduce this topic of what is a data center today. This topic is foundational to the series, and while you don't need to participate in these webinars in sequential order to understand what's being shared, we thought it most pertinent to begin with what is a data center to ensure that everybody begins the series with a level set understanding of what we're talking about and why. So Mohana, I am happy to pass the baton to you to lead this conversation.
Thank you for the introduction, Dr. Janet. I'd like to share my screen. Just a second. So today I'm going to talk about what is a data center, and the main goal is to understand what it does, why it matters right now, and what its environmental footprint looks like. So when we want to understand what is a data center, a data center is a facility designed to host computing systems and associated infrastructure that is required for continuous operation of the data center. It integrates servers, storage systems, networking equipment, power systems, cooling technologies, and security mechanisms to ensure uninterrupted service delivery. So here we can see that a data center has all these equipment in it, and it provides access to the internet, and a visitor gets the access to all these facilities through the internet. So I want to give you a brief background of how the data centers have come into play. So in the early era, that is from 1990s to 2000s, we can see that the main focus of the data centers was on performance and uptime. Uptime measures how long a system or a network is being used in a given period of time. And then they were only using fossil fuel grids, so there were no sustainability goals. And they used to use mechanical cooling, which draws a lot of energy. And then there was a transition in 2010s in which cloud computing and virtualization improved efficiency. Energy demand still rose with the data growth, but sustainability goals were discussed and talked during that time. And now in the modern era, that is 2020s to present, the most of the data centers are driven by AI, IoT, and hyperscale expansion. So the main focus is on carbon neutrality, water reuse, and circular design. Integration of renewables, hydrogen, and battery storage is a big thing right now, and most of the data centers are trying to adapt it because there is no available grids for them. So when we are talking about the data centers, why is this topic being heard a lot right now? So the data centers power our everyday life. We need them from internet, AI, cloud apps, maps, banking. We use it every day. So the main problem that we are facing right now with the data centers is the sustainability problem. The energy demand is surging. The data centers energy usage could almost hit 1,200 terawatt hour by 2030, which is stressing the global grids. The emissions are also raising, so their global share of CO2 is going to nearly double in the coming decade, and the clean energy is lacking. Keeping up pace with the costs, and the integration of the renewables and the land requirement is leading the data centers to be increasingly carbon locked. I want to tell you the carbon locked data centers mostly use fossil fuel grids or diesel generators as a backup, and that is leading to more carbon emissions. So what is driving this market growth of the data centers that we are discussing? The main culprit here is the AI workloads and digital transformation. Generative AI and real-time analytics demand massive compute power, driving hyperscale data centers to build larger data centers and GPU optimized data centers. Cloud computing adoption has been taking place since past 2 decades. So the enterprises are moving to cloud native architectures. So the apps that are designed to run and scale in the cloud are called cloud native architectures. This is for speed and efficiency, which is pushing Amazon Web Services, Azure, and GCP to expand worldwide. And there are a lot of localization regulations. So there are some laws that require sensitive data to stay within the national borders. So this is accelerating regional data center investments. And with the recent growth of 5G and edge computing, we can see 5G is leading to ultra low latency needs that is pushing data centers closer to the users, which is enabling autonomous vehicles, smart factories, and Internet of Things. So, why are AI data centers very different from the traditional data centers? We see that data centers were also there in the past, but why are these AI data centers very important and different? So these AI data centers use GPU clusters instead of traditional CPU systems that we used to use a decade before. So much higher power density is required by these GPU systems. So the AI racks could exceed up to 100 kilowatt per rack. And this generates extreme heat, and this requires advanced cooling systems to cool the servers, which are generating a lot of heat. So, to operate with high variable and intense workloads, the energy consumption usually increases because there is a lot of jitter. The power consumption changes within seconds, and to power the data center with that jitter, we need a lot of energy, and therefore we need a lot of water to cool down the servers. And then they drive significant greater demand for energy, water, and infrastructure. So I would like to discuss what types of data centers are there right now. And so we mainly have four types of data centers. The first one is enterprise data centers, which are dedicated to a single organization. Then we have the hyperscale data centers, which are large scale facilities that provide global services to platforms like Google, Amazon. And then we have co-location data centers, which are shared infrastructure by multiple users and multiple organizations. And then we have the edge data centers, which are very small facilities that we talked about in the previous video that they have shown. These are very small facilities, and they can go unnoticed, and they are very close to the end users. So when we talk about the energy consumption in the data centers, what is consuming most of the energy? I would say the IT equipment in the data centers and the cooling loads in the data centers consume most of the energy of the data, which perform the computational tasks, the storage systems that maintain data availability and integrity, the network equipment that facilitate for reliable electricity and electricity supply, and there is a backup electricity if something goes wrong, and cooling systems that manage heat generated by computing processes. So what are the core functions of these data centers? They host websites and applications. They store large-scale data repositories. They process transactions and digital operations. They enable cloud computing services, and they support artificial intelligence and data analytics workloads. So we keep talking about reliability and the data centers having uptime and them being powered 99.9% of the time. Why is it so important? That is the main question that we have. So the data centers are designed for near continuous operation due to the critical nature of digital services that they give. So some businesses and industries such as healthcare, e-commerce, and finance require continuous availability with minimal downtime. So to achieve this, they incorporate redundancy and backup power systems. The backup power systems are usually diesel-based generators and advanced monitoring mechanisms to make sure that the power is being continuously delivered to the data center. So reliability is often measured as uptime, which I have mentioned in my previous slides. It is a defining feature of the data center performance. So when we talk about reliability and the data center being powered 99.9% of the time, there are consequences that come with it. So the energy consumption of the data centers is at scale. So in the graph that I have created here, we can see that the energy usage of the data center is going to be increasing fourfold in the coming decade. So by 2035, the global data centers could consume around 1,200 terawatt hour of electricity annually, which is equivalent to roughly the combined electricity usage of 15 to 20 Kentucky continuously can approximately use 872,000 megawatt hour annually, which is equivalent to the electricity consumption of a small city. So how do we make sure that the data centers are using the power that they're taking in effectively? So there is a factor called power usage effectiveness factor. So it is defined as the ratio of total facility energy consumption to the energy used by the IT equipment. So lower PUE values indicate that there is a higher energy efficiency with the data centers. So PUE here is does not indicate the carbon emissions, water consumption, embodied carbon, or the total power demand of the data center. It's just a ratio between the total facility power with the IT equipment power. So efficient growth can still happen with increased environmental impact because I'm sorry, because it is important for us to have renewable energy integrated into the data centers. Moving forward to the next slide, I would like to talk about what this efficiency means in practice. In this slide, you can see that there is a decline in the PUE numbers, which means that the efficiency is increasing day by day, but there is still scope for a better efficiency energy usage in the data centers. So the data centers are amongst the largest electricity consumers globally, with significant energy consumption that driven by IT equipment and cooling. So the average PV for the data centers is around 1.56, with leading hyperscale data centers achieving around 1.08. So the best theoretical PUE here is 1, and it's not possible to get a 1 PUE for the data centers. So the real world PUE that can be achieved right now is around 1.08 to 1.1, which is achieved by top hyperscalers in the industry in ideal climates. So going to the water usage of the data centers, we can see that the global cooling water use of data centers is projected to increase 570% between 2015 to 2035. So by 2030, global data center cooling could consume waters comparable to the total annual withdrawals of several states like Kentucky, Indiana, and Ohio combined. So with all of this water usage, there is a water risk and site selection that has to be optimized for the data centers. So the data centers are operating mostly in drought-prone or arid regions, which limit the freshwater supplies and increase the competition with local communities and industries. So there is a aquifer depletion that has been seen in most of the places that the data centers are operating. So there is a heavy groundwater use that can accelerate aquifer decline, and long-term risks also include ecosystem damage and reduced water availability for surrounding populations. There are also some regulatory risks that are involved. So the governments are tightening rules on industrial water withdrawals and discharge, and sites in high risk regions may face stricter compliance requirements and operational constraints. So here I would like to highlight the case of Northern Virginia, which is the global data center hub and is also called as the capital of data centers. This is a case study. So this region hosts around 300 data centers across Fairfax, Loudoun, Prince William, and Fauquier counties. And all Northern Virginia data centers use around 2 billion gallons of water in 2023, and that is a 63% increase since 2019. Loudoun County alone, which has 200 data centers, consumed 900 million gallons of water in 2023. And Loudoun County increasingly relies on potable water for data centers due to limited reclaimed water capacity. So when we go to the carbon impact that comes with both water usage and the energy usage of the data centers, we can see that the energy consumption alone does not impact the environmental impact. So the carbon emissions also depend upon the energy mix supplying the electricity. So we can see that the carbon emissions are going to double by 2035, that is in the coming decade. And the data center carbon emissions are projected to rise around 80% between 2025 to 2035. By 2035, the global data center carbon emissions could reach a level comparable to roughly 170 million typical US passenger vehicles, which is massive. So, when we talk about the energy sources, could define the carbon impact that is being generated from the data centers, we can see that each of this renewable energy source comes with a different trade-off. So solar or wind might need more land, and hydro might need more water. So each of these has a trade-off, and siting the data centers properly is a very big problem. So the energy sources here differ significantly in land requirements and megawatt hour per installed. And also each technology exhibits varying electricity output performance over its lifetime. And carbon emission intensity varies widely, influencing sustainable outcomes and siting decisions. So there are some broader environmental impacts that we can see. So the embodied carbon in construction materials of the data centers and electronic waste generation from the data centers, as well as the backup generator emissions and land use and infrastructure development of the data centers, they all contribute to some or the other environmental footprint. So we talk this much about data centers, but why do communities still need data centers? These are some of the important points that we need to emphasize on. So the data centers bring economic and digital benefits. They power our everyday lives, so we need them for sure. And they also bring tax revenue to the local governments, and they also bring in job creation, AI and tech investments to the region. They also get cloud infrastructure, and they bring in regional development. All of these are very much important for the community. So what are the community and environmental concerns that everyone is talking about? So the main concerns are high electricity demand, water consumption, grid stress, land use impacts, and emissions and sustainability. So some of the data centers are having sustainability goals that they see that they'll achieve in the coming decade or so. So what are those sustainability goals? So some major operators are pursuing ambitious goals, including achieving carbon-free energy usage, reducing life cycle emissions, transitioning towards net zero operations. These efforts highlight the importance of efficiency and clean energy sourcing. And there are also many case studies that talk about green data centers, which have zero emissions, and there is a lot of research going on in that area. So, what makes a good data center location? The key factors that we talk about in a data center site selection are reliable power grid infrastructure, access to renewable energy sources, water availability for cooling systems, affordable land and infrastructure costs, favorable climate for efficient cooling, government policies, incentives, and regulations. All of these factors have to be considered when the designers are actually considering to build a data center in a location. There are also some community and environmental considerations that they need to consider. What are the future trends in the data centers? So the emerging directions are liquid and immersion cooling, low carbon infrastructure design, renewable powered campuses, small modular nuclear interest is increasing day by day, but containment is being an issue. But I think they might reach to a good point in the coming years. And edge AI computing and waste heat recovery are the most emerging topics in the data centers research. So, in conclusion, I would like to say that the data centers are the backbone of modern digital world. AI growth is rapidly increasing demands for energy, water, and infrastructure. Sustainability depends on efficient design, clean energy integration, and responsible siting. Balancing economic benefits with environmental impacts is becoming increasingly important. So the final takeaway from this talk is that the real challenge ahead isn't deciding whether the society needs the data centers. We need it for sure. So the challenge is understanding what the society needs from them and building an AI era infrastructure that is responsible, resilient, and aligned with public expectations. Thank you.
Thank you, Mohana. Appreciate what you have shared. So I'm encouraging people to go into the chat to share their questions. If you have questions and want to raise your hand, please go ahead and raise your hand and you can be entered into the queue to ask your question out loud. And there's already some questions that are here in the chat. So I am going to dive into some. There's a question here from Terry, Mohana. Terry asked, what is the life expectancy of the equipment? What happens to the equipment at the end of its life? And I think this is an interesting question because in thinking of what's sustainable and thinking about the lifespan of data centers, we've got to think about all of the entire complete life cycle of it, including what happens afterwards. I'll just read a comment that also came through from David around the same time, sharing that most IT equipment gets about a 5-year life cycle due to warranties and licensing. So all of this mass hardware is going to need to be replaced every 5 to 10 years. So what are your thoughts on the life expectancy on equipment and what happens to it at end of life?
So, from what I know, the most of the servers need to be replaced in 2 decades usually. The performance starts declining usually from 10 years, and then when the performance is really bad and there is newer technology, there is a scope for them to recycle some of the materials that they use. And the other waste is just electronic waste that is produced from the data centers. But yeah, with rapidly growing technology, we keep getting a lot of new technology, and that is actually leading to more changes, and that is leading us to like get newer servers day by day, which are more efficient and resilient, and and they might also be better in terms of the heat that they are generating. So yeah, it depends upon how fast the technology changes, and based on that, they might actually change their servers based on the performance of the servers, or they and if they really do change it, they might actually recycle some of the materials that they use. Yeah. Uh, uh, Dr. Janet, you're on mute.
I wonder how far I would have gotten into that. Thank you so much. We have a comment that's next from Alicia from Union of Concerned Scientists about a report that they have. So please be sure to check out the report about clean energy and rising electricity demand. As well as the climate and health benefits. And then I want to raise a question that's here from Peggy. The Kentucky legislator has given tax breaks to data centers built in the state. How do these tax breaks offset tax revenue to the communities in which these data centers are built? Do you have some insights there, Mohana?
Um, I'm not very much I don't know much about the tax incentives that they receive, the data centers receive. But yeah, they actually generate some revenue to the state for sure. But creating a balance between the revenue that they receive and the community concerns is really important right now. So,
Thank you. Thank you for your
yeah.
thoughts on that. And there is a response to that that's here in the chat from Byron Gary of Kentucky Resources Council, who's actually one of our speakers later on in the series. So stay tuned to hear more from Byron. But what Byron shares in response to the question on the tax benefits is that the tax benefits adopted by the state are sale and use tax exemptions. Local taxes are generally property taxes and unaffected by the state. That said, many localities negotiate specific property tax exemptions or abatements to attract large economic project development. So it largely depends on the specifics of any local agreements. Very, very insightful. Thank you so much for sharing. Okay, we've got many more questions for you. People have lots of questions about these data centers. Um, so another question that we see here is from Tessa. What kind of natural resources are required for data center hardware? Are there issues to consider with the extraction and labor?
I'm sorry, I didn't get the question.
Oh, okay. Let me repeat that. From Tessa, what kind of natural resources are required for data center hardware? And are there issues to consider with the extraction and labor? And I think this question also speaks to that complete life cycle of a data center.
Yeah, so in terms of natural resources, what what is the exact meaning? Like, what kind of materials do they require? Is that what she
Yeah,
means?
what kind of material? I'm assuming this is what kind of materials do they require? What type of raw materials? But Tessa, if you are able to come off mute, we welcome you to add some clarification.
Hi, yeah, sorry that my question was a little confusing, and I was trying to pull up some articles, but just in some of my independent reading, I've seen that a lot of the hardware for these data centers are being extracted globally, and there's a lot of labor issues with the amount of natural resource. So I was kind of a leading question that I know a little bit about, but I was wondering if you could speak to that, or anyone else in the room who have considered these types of issues in terms of what else is required. Dr. Janara, I think what you were saying with like the life cycle, yeah, is kind of what I was getting at. Thank you.
So, yeah, we can actually substitute some of the materials that they're using currently with something called green concrete or steel slag. And there are also some sustainably sourced wood that can be used in the data centers. So, I mean, for sure, we do need to find better alternatives to some of the currently used materials,
Mhm.
but yeah, I don't think it's much of a concern right now because most of the concern that is coming is based on the energy and water consumption, and that's where the people are actually focusing. And from an infrastructure point of view, that's I think something that the civil engineers would actually have a better idea about. Yeah.
Thank you, Mohana. Yeah, I appreciate the thoughts that are coming into the discussion about not just the energy use, the high energy and water use demand that comes with using data centers or operating data centers, but also everything that goes into it, and how to take account of all of that to better understand data centers and their impact. Okay, we have a lot of questions for you, and I am doing my very best to keep up with them in order. But I'm sure people will correct me if I miss their questions. So the next question that I'm seeing is from Bev. And Bev asks, who will provide oversight to compliance? And Mohana, if that is over your head, totally understand.
Oversight to compliance of the data centers, right?
Uh-huh,
I
yes.
think I think it's mostly the government. I think
Mhm.
there might be a sector that actually looks into it, and the companies need to report some of the things openly about how much their emissions are and how much intake of electricity they're having. So I think that is mostly reported to the local governments.
Okay, thank you. Very helpful. And then we have a question from Maggie. And thank you, Maggie, for being here, and thank you to PSR for your support of this series. What are the best ways community members can advocate for environmental sustainability in places where major data centers are already being built? And you gave an example of one in Northern Virginia where
Yeah.
there are 300 data centers just in Northern Virginia alone. So how can, what do people need to know about sustainability, and what should people be looking for in terms of sustainability in data centers? And to Maggie's question, what are the ways that community members can advocate for environmental sustainability in data center development?
From our recent conversation with a person who works in data centers, um, most of the data centers are actually relying on natural gas or some of the other renewable energy sources, but they also use the diesel generators for sure. So
Mhm.
that's leading to emissions. Uh, this is because they can't draw more than certain electricity limit from a grid, and most of the regions are already being strained. So I think there is a lot of opposition that is coming out from Northern Virginia. We have read a lot of articles, and from there, we have also seen groundwater decline and people complaining about it. And I think government is doing its part in actually looking into all of those issues that they're facing. And probably it's just the people's voice that could actually do something that actually leads to some improvement in the situation. Yeah.
Do you have
And
some insight on where people might find more research on sustainability in data center?
yes, so right now there is a lot of research that is going on in like integrating 100% renewable energy. And also there is a lot of research on green data centers. They're being widely seen in China right now, not in US. So probably we might actually see it in the coming future. But yeah, there is also a lot of research on cooling technologies,
Yeah.
air-based cooling, immersive cooling, etc., which might actually reduce the water usage, and that could actually lead to better sustainability. Um, And I think water usage effectiveness factor also should be considered here, and that data should be sent out to the communities that are living near the data centers. It has to be posted on the data center website so that
Wow.
people get a better idea.
Oh, very interesting. I think that raises a number of questions, as some data centers, it's discrete and you cannot tell by looking at it. Who is this data center? Who owns this data center? And then some have their company name on them. And then I appreciate raising of the issue of the diesel generators. These can be a source of noise for the local community and also more obviously a source of emissions for that local nearby community. Do the generators have to be diesel? Are people exploring other sources for the backup energy in data centers?
Yeah, there is a source of getting the backup energy from battery, which is actually being proposed by Tesla. And
Hmm.
also, but diesel generators are comparatively cheap, and the organizations that can't afford expensive batteries as a backup usually go for the diesel generators. And noise is obviously a problem that they face when they have a lot of diesel generators to power a facility like that.
Hey, well, thank you for adding some more context there. We have a million questions, so let me stop sneaking my questions in between these questions so we can try to get through most of them. So I have a question from Heather here and a comment from Catherine, and the subject is jobs. On one of your slides, you talked about jobs in communities. So is there data on the number of permanent jobs rather than temporary construction jobs that are created by these data centers? And I'll note a comment and that's from Heather, and I'll note a comment from Catherine, um, sharing that data centers can employ 100 to 200 people, can be significantly less, can be more. And I would offer potential commentary that this 100 to 200 is more of the range of the temporary jobs and the development of the data center. But I'm going to leave it to our expert. I'm handing it off to Mohana. Thoughts on jobs?
So, while talking about jobs, there are a lot of temporary jobs for sure are created when a data center is being constructed. They can power the construction sector and the energy sector for sure. But the permanent jobs that are created by the data centers widely depends upon the scale of the data centers. So if it is a hyperscale data center, they could be around 100 data center technician jobs, more than 100 for sure in bigger hyperscale scale data centers. But in the smaller ones, it could be around 20s or 25 employees. Yeah.
Yeah, those
I
match
do
with.
have some data, and I can share it
Oh,
after this meeting is done.
oh,
So yeah,
thanks.
maybe we can use that.
Absolutely. We would be glad to add it to the resource library. We see a few people have dropped some links in the chat, and we'll add those to our resource library as well. This is a question that comes up often. Does it really bring jobs? How many jobs? And so thank you for taking time to share on that. Um, let's see. Do you have thoughts? There's a question from Phyllis. She raises a question or a concern around servers that last 10 years. What's happening though to the retired servers? Coming from Phyllis.
So uh, I would like to draw a similar example. So let's say we have iPhone 4 for say, and now we are in what iPhone 17, right? So iPhone 4 is obviously slower than iPhone 17. So what do? We discard them, and it's going to be e-waste. So it depends mostly upon the efficiency. Maybe some people could use it in smaller data centers. The discarded servers, but the energy draw is going to be obviously higher when compared to the newer servers and newer technology that they're developing right now. So yeah, some of the servers could actually be e-waste, and some of them could actually be used in some smaller data centers for sure. And that is how I think it works usually. And yeah.
You gave me a blast from the past. It took me back to my iPhone 3GS days, to think about where technology has come from then to now. But then our exploration here of the potential social, societal cost of that.
Mhm.
There is a cost to advancements in technology. So many more questions for you. If you can help level set, to make sure people are on the same page of understanding about kilowatts and megawatts and what it all means in terms of the size of data centers, can you break that down a little bit for our understanding?
So yeah, the smaller scale data centers, they usually I don't want to be very scientific about it so that a normal audience could actually understand this topic. So the small scale data centers could actually draw the power of a community community, and the larger scale data centers per se 400, if I say a 400 megawatt hour data center,
Mhm.
it is going to draw the combined electricity usage of a city like Lexington and Frankfurt combined, or city like Louisville, if it is not very efficient in its energy usage. So yeah.
Wow. So essentially, the current hyperscale data centers, were I'm also thinking there's some really huge ones, but on average, what we're talking about, is uses the amount of power that a whole city would use, a city the size of Louisville. Wow. Okay. I think that may help add some insight to this question slash comment from David. David shares that the company I work for processes a third of the world's gift card transactions with about 40 kilowatts. That's roughly 10,000 less energy than the West End data center currently under construction. And that's the Louisville West End data center currently under construction. How can we pretend anything about this is efficient or sustainable?
So I think probably it depends upon the energy mix that the data center uses actually. So if it is being powered by solar, wind, or natural gas, I don't see very a big impact on the community when compared to the data centers that are based on grid. But yeah, it varies widely from a data center to another. So Google is trying to actually get data centers to a 1.08 PUE range. But yeah, there are some data centers which don't have that scale to actually do that kind of research and have that
Yeah.
yeah.
Okay, so it's becoming clear to me. We may not make it through all the questions. I want to encourage people, as Dr. Joy Hart has done in the chat, please go ahead, drop your questions in the chat, even if there might not be enough time to discuss them today. We're doing this 5 or 6 more times. So there will be many opportunities for your questions to get answered. We'd love to have your question on record, and we'll be happy to share them with the presenters. So Anjali, thank you so much, Anjali, for being here. Has a question here. Anjali has a question here. The environmental footprint of data centers is large. So siting needs to be done carefully. Do you have any thoughts on the siting or where we are locating these data centers?
So yeah, we have worked on an NSF proposal with Dr. Smith and rest of the team. So yeah, we did have the main part of that proposal was siting. Siting is very, very important when it comes to data centers. keeping the data centers away from the people could actually increase the latency problem. So where the farther they are, the slower the AI and response is going to be for us. So we need them
Interesting.
near us, but it's going to be the environmental risk that we will be facing is going to be a concern that we need to deal with. So sighting is a major problem, and we are trying to check if we'll be able to see some potential sites that are not very far from the communities, but they don't actually use up the resources that the communities use. So yeah.
Okay. Oh, I think that'll be the key that continues to come up in our conversation. And it's really interesting. In the video we showed, I think I said that Google said to cite them away from people. And I think that what you have shared is that that poses an additional challenge, because then that makes it take longer for the data provided by the data center to get to the people that are using it. So does that mean that data centers, and this is your last question, should be evenly dispersed across the nation, or evenly dispersed based on population size that's being served? Or where can there be some levers pressed on the locations?
So when we talk about possible locations, we actually had a thought on providing a GIS-based service for the data centers, locations in which they can actually look up for the nearby power sources and site them close to some water reservoirs and the places that also have abundant renewable energy with them. So um, it's a very complex question. The siting itself
Yeah.
is so complex that we don't want the community to be affected by it, but we also need the data centers near us. And not a single person here in this call wants the chat GPT to answer us like in 5 minutes after we ask it a prompt. So we need immediate answers from AI. And yeah, that's a huge problem. We actually want a latency-free service from AI, but we also need siting to be somewhere far from us. So it's more a research question, and
Yes.
probably in near future we might able to find a better answer to it. But right now it's just that we need to find better locations for the data centers where there are renewable energy sources and better water could be actually used for the data centers. So yeah, it it is a complex question. Yeah.
It is a complex question. Oh, goodness. I love that we are going to round this conversation out on this complex question. We are at time. I have shared a survey link in the chat, and it appears that's not the right link. I'm going to share a QR code here on the screen pretty quickly. I'll also follow up via email to make sure you can share feedback. Thank you for attending. Thank you to our esteemed presenter for sharing your expertise today. We are so appreciative of your time, Mohana. We are so appreciative of you taking time to answer our many questions. As you can see, there are a lot of questions on this, and with Mohana's last comment, I don't know that any of the answers are quite as simple as we would all like them to be. I think I can agree we would like the answers to be simple. That just makes life easier, right? So Mohana, thank you for being the first speaker to kick off this exciting series. Thank you all for your participation. Thank you to the Christina Lee Brown and Byram Institute for hosting this, along with Greenheart Louisville and UofL Superfund Research Center. And thank you also to PSR Physicians for Social Responsibility for sponsoring. Stay tuned for upcoming topics in the series. Next week, on June 10th at noon, Join us as we learn about data centers and health from Latricia Adams of Young, Gifted, and Green. All of our webinars will take place on Wednesdays at noon. You can join any and all, and please share. Sharing is caring. Share this with your networks. I would be remiss if I didn't take a moment to share with you about our upcoming Food and Science Forum. So if you're in the Louisville area, this will be June 11th at Bates Memorial Baptist Church. There will be a farmer's market that starts at 4 p.m. and an expert panel discussion that begins at 6 p.m. And if you don't live in Louisville, yes, you can still watch the panel live. It'll be live streamed by following Bates Memorial Baptist Church on their Facebook or YouTube channels. Lastly, you can stay connected by visiting us online at centers.louisville.edu/environ. Stay up to date on upcoming events by visiting our events webpage, and you can also follow us on our socials at UofL Environ. Thank you so much.